Did you know nature has been kind of hiding things from us? Rare moments that take place in the sky, on the land, or in the sea that are so subtle and so fast, we barely notice them. Until now. You're about to find out the true shape of a rainbow and what happens to light when it hits a butterfly. I'm Mike with List 25, and these are 25 natural moments most people miss in their lifetime. 25. Circular plane glory. Here's a mind-boggling fact I never knew before. You can see colorful circles in the clouds when you're on a plane. Look out the window, and you'll see perfect circles inside your own shadow, which are called glories. These are formed when light bends around the water droplets in clouds, a process known as diffraction. Red, blue, and violet rings are created as the light bends and scatters. A glory is often mistaken for a rainbow, and while they're similar, they're different things. That said, a glory circle can teach us something surprising about rainbows. You see, a rainbow isn't actually shaped like an arc as you might think. Its true shape is that of a circle, just like a glory. The only reason we think it's an arc is due to the cloud cover, which obscures some of it. Now that we know that fact, we can fully appreciate the glory of rainbows. 24. Desert bloom. Nothing grows in the desert, right? Wrong. You can actually see flowers there, but you need to be super quick. So-called desert blooms come and go rapidly, meaning most of us never get to appreciate the beauty of this rare and spontaneous natural event. Thankfully, this fascinating spectacle has been observed by others who've recorded what goes down. Or should I say, what sprouts up. The Atacama Desert in Chile is desert bloom central, where rain triggers unexpected bunches of wildflowers around every 3 to 7 years. It's been noted how the flowers grow several weeks after rainfall in Atacama, transforming the dry landscape. Unfortunately, the bloom doesn't last long. Sometimes it only stays for as little as 1 week, though it can go on for a few months if you're lucky. The thing about a desert is, it's usually hot, and once the heat comes back, it drains the moisture from the plants. They only had a tiny amount of water to drink in the first place, which is sad, but a brief life is better than nothing. 23. Earth briefly grabs a second moon. We know Earth has a moon rotating in our orbit. However, the idea of a secret second moon that not many people know about is enough to blow your mind into another dimension. This moon is actually a mini-moon, or an asteroid drawn into our planet's orbit, where it becomes part of our gravitational system for a couple of months. The mini-moon isn't locked into orbit or anything. It gets dragged around a little before breaking free and going on its way again. Experts believe we've had several join the party and then leave over the centuries. 22. Needle ice. Did you know there are small needles made of ice that grow out of the ground? These sharp and frosty points are formed by a combination of air and soil temperatures. When the air is freezing cold, but the ground is slightly warmer, this contrast draws moisture upward, where it forms into needle-like shapes. So-called needle ice grows in remote locations such as the Italian Central Alps, but you'll find it in more accessible places. Some call this phenomenon a frost pillar, or a frost heave needle. Whatever the name, it grows a few inches. Sometimes as high as 16, though this is rare. The fact that needle ice grows in inches rather than feet, plus the fact that it has a limited lifespan, might explain why so few people notice this incredible natural moment. 21. Spiderweb pearls. Our next natural moment is more familiar, but still a precious thing to witness. Spiderwebs covered in droplets of dew are something you may have spotted in the morning while walking to work. They're more noticeable than most because the morning sun catches the dew and makes it sparkle, like the spider caught a bunch of diamonds in its web. Of course, this is a totally natural process. But how does it work? Spider silk is highly textured, with a puffy quality when dry. As the morning begins and the air gets moist, the condensation changes the surface tension of the silk. Water then gathers and forms into large droplets on this new texture, hanging in position on the web. Nothing lasts forever, though. The sun highlights the dew, but it also causes it to evaporate, making this a beautiful, yet short-lived moment of wonder. 20. Ephemeral Fog Bows. You've heard of a rainbow. Well, what about a fog bow? A bright circle effect is created in the air when the sun hits the fog, thanks to tiny droplets suspended inside it. Unlike a rainbow, it has a subtle appearance, with a lack of bold color, though it's far from invisible. The other main difference between a fog bow and a rainbow is how they bend light. Rainbows refract sunlight, so it bends as it meets a new object. Meanwhile, fog bows diffract light, which bends light around obstacles, working in a more flexible way. Another way to think about it is that rainbows are a more colorful, magical sight, whereas fog bows have been compared to ghosts. So they're more unnerving than anything. The size of the droplets in fog is also important. Because they're microscopic, the fog bow effect doesn't last long. That's why we call it an ephemeral fog bow. 19. Forest chemical alarm. This moment is one you are bound to miss, which isn't your fault. It happens on the down low, at least as far as our five senses are concerned. The forest, on the other hand, is sounding an alarm, reacting like it's in a war zone. Chemicals get released into the air, and these are intended as a serious warning. A warning about what? Well, the problem with being a plant in the forest is that you aren't just left alone to grow. Insects will use you as a food source, meaning plant life, like trees, need a warning system for each other if they see any hungry bugs coming. Chemicals called VOCs, or volatile organic compounds, let fellow trees know there's a threat. Trees have been known to thicken their leaves, making them harder to consume. If that wasn't fantastic enough, the chemical alarm has a nasty surprise for the insects. They attract predators of the forest, who in turn eat the insects. These predators include birds and even other insects like wasps. Seems like trees aren't as harmless as they look. I mean, ask Saruman about that one. 18. Crepuscular Rays. It doesn't have the most exciting name, but believe me, this natural moment is too good to miss. Crepuscular light rays happen at twilight, or sunset, when sunlight peeks through the clouds and passes through the atmosphere. Dust in the air scatters the light, having a dramatic and beautiful effect on the sun's rays. Instead of seeing a full spectrum of color, the scattering light takes shorter wavelengths, like blue and green, out of our field of vision. We're left with the remaining colors of orange, yellow, and red. These are what we associate with a setting sun, and we find them comforting. This sight can be easy to miss because sadly, we don't look at the sky the way we used to anymore. If we could just tear ourselves away from our screens and look up, we'd think twice before scrolling through social media for the 1,000th time. He said on YouTube, a kind of social media site. Don't forget to like, comment, share, and subscribe. Woo! 17. Algae blooms in puddles. Getting caught in heavy rain isn't exactly the best experience in the world, but it does have surprising after effects. You see, algae has been seen growing in the puddles that are left behind. This type of algae is a little more colorful and less icky than what you'd find in a pond or on your patio. It's said to bloom, kind of like a flower, producing colors beyond the standard green. You can see blue and even red as the sun breaks after a storm and the light supercharges the microbes in the water. The rain provides the nutrients for the algae to grow, and the sun creates photosynthesis, though much faster than usual. Why aren't more people aware of the algae? Firstly, you don't automatically connect algae with puddles. Secondly, most people are busy trying to dry out indoors, not splash around outside. 16. Midnight sparks of lightning bugs. Lightning bugs, or fireflies, flutter around, glowing in the air and looking beautiful. A swarm of them may seem like a random thing, but the reality is anything but. In fact, lightning bugs have been seen flashing their lights in sync, performing a kind of dance. This process is called synchrony, with thousands of luminous insects dancing together as they blink on and off. The synchrony has only been seen in a small number of firefly species. Why do they do it? In 2020, researchers at the University of Colorado Boulder filmed a swarm of male bugs before reconstructing their dance in controlled conditions. They learned that the rhythmic flashing action only happens when they're in a group. It's a social activity for them. However, they're not just hanging out. The dance also happens for an important reason. Namely, the males are looking to draw attention to themselves so they can attract females and mate. So, you know what? Maybe I'll just buzz off and let them get on with that. All right. I pointed that way and going this way. Don't worry about it. 15. Micro moments of a hummingbird. The hummingbird is beautiful, aerodynamic, and, of course, it hums. It's also a marvel of natural engineering. The way this little creature uses its wings is so impressive that it makes airline companies jealous. You see, the hummingbird doesn't just beat those wings up and down, it moves them in a figure 8 pattern, flapping them between 40 and 80 times per second. This is a surprisingly complex process that sees the bird hover in midair, looking like someone pressed the pause button on nature. It took years to work out exactly how the hummingbird hovers, with US academic researchers creating a computer simulation. This showed how the figure 8 pattern generated powerful forces in both the up and down directions, helping the bird stay in position. It's comparable to how insects fly, making the hummingbird more like a dragonfly than a bird. 14. Transient desert mirages. If you're unlucky enough to be stuck out in the desert, you might experience a transient desert mirage. This is a powerful optical illusion where your senses play tricks on you in the harsh conditions. You may have heard of them before, thanks to their appearances in movies and shows, but you probably don't know how they happen. While the desert is usually baking hot, there are differences in temperature depending on where you are. The sand is superheated, however the air is cooler. Take the Sahara Desert, for example, where the sand can be a scorching 176 degrees Fahrenheit, significantly higher than the air. This difference can actually bend light waves, resulting in the mirages. The light is refracted due to change in air density. Because the air is thinner, closer to the sand, the light curves when it travels from the denser air up above to the lighter air down below. That's why you think you see a lake or a floating city, even though there's sand for miles around. You can actually kind of do that when driving on a highway. On a long stretch, you can kind of see what look like puddles, and you get there, they're not there. 13. Tiny dew bows. So, you have rainbows and fog bows. But have you heard of dew bows? They sound like a Pokemon, but they're easily missed by most people and look like miniature rainbows. How many are we talking? Well, the bows are only visible on dewdrops and can literally be described as rainbows on a microscale. Just as big rainbows refract and disperse sunlight, so tiny dew bows take light and bend it. The light is divided into separate colors, producing the same magical effect. Trouble is, you may need a magnifying glass to see it. 12. Sand ripple impact. If you think a sand dune is simply a bunch of sand all stuck together, then think again. The dune has a beauty all of its own, which you can glimpse if you watch closely. These sand ripples happen when the wind disturbs the dune. There's a technical name for this, aeolian transport, which sounds like something from a sci-fi movie. Another name is the impact splash mechanism. Who knew grains of sand could be so exciting? Although they are coarse and get everywhere, but that's besides the point. The mechanism works by shifting the grains around, meaning the dune sand ripples because it's bouncing and impacting against itself. However, that's not all. You see, as the sand vibrates, it makes a sound, and this has been compared to whispering or music. So, you not only see this natural moment, you hear it. 11. Butterfly light. What happens when sunlight hits a butterfly? Something incredible, that's what. A butterfly's wings have scaly structures that interact with the sun's rays. These structures diffract the light, or bend and spread it out. The result is a kaleidoscopic display of colors. Blue, green, gold, and violet have been seen during this rare and beautiful natural moment. In order for it to happen, though, the sunlight has to strike the insect at just the right angle. That's why so few people know about it, unless you're studying the creatures and paying close attention. The sun also has a positive effect on the butterfly, which uses the energy to warm itself. It really needs the solar rays because it's cold-blooded. When its wings glimmer with all those colors, you're basically watching it power up. 10. Tidal Sandbars. You may have wondered what those exposed strips of sand are between the water at the beach. These are sandbars, and they're a natural feature where the waves part to allow the land to peek out at the surface. Why do they part? Because the sand has become more prominent. The water is temporarily unable to wash over it. Okay, so how did the sand get like that? Well, further out to sea, the sand was picked up by the tide. It was then carried toward the coast, where the momentum of the tide dropped it. The buildup of grains eventually obstructs the tide, creating the bar of sand. Ultimately, the tide wins as it keeps flowing while the sand is disrupted and pushed away again. You also have shoals, which are similar to sandbars, only they stay underwater. They can sometimes be made of gravel too. Shoals are potentially hazardous to boats that can't see them, and sometimes run into them with disastrous consequences. 9. Inversion Layer. Did you know that the sky can stop thunderstorms? Just as people put up umbrellas to stop themselves getting wet, so the heavens use something called a temperature inversion layer to keep a lid on any wild weather. It happens when the Earth's surface cools, typically at night. There's warmer air above, which naturally sinks down. However, the cooler air below is stronger, so the sinking warm air sits on top of the cool air. It suppresses the air, meaning a storm can't break because there isn't the meteorological movement for it to do so. Plus, this layer can be punctured, which releases the pressure and provides the conditions for storms to finally happen. 8. Langmuir circulation lines. Foam can do freaky things on water, as Langmuir circulation lines show. They're the result of a natural process, where wind pushes foam across the water. This generates vortices, or rotating sections below the surface, which hold the foam in a line. They get their name from Irving Langmuir, a US physicist who worked out why it happened back in 1927. He noticed the lines of foam while traveling across the Sargasso Sea, though the effect can be seen in different bodies of water, from oceans to lakes. It doesn't just affect foam either. Whatever is floating on top of the water can become part of the circulation line. Seaweed and even junk and pollution are collected in the vortices. You need to be quick to see them, as they fade away pretty fast. 7. Vortex Streets. We think of a whirlpool as one thing, but a von Karman vortex, or a vortex street, is a whole chain of them. How are they formed? It happens when a moving body of liquid comes up against an obstacle, like a rock. The water divides as it tries to get around the obstacle, and in doing so, it slows down a little. When it flows off the rock, it starts moving in an eddy-like motion, spinning in separate little whirling patterns. They're connected with Theodor von Karman, a Hungarian-American engineer. The name Vortex Street comes from the parallel lines formed by the vortices, which can be compared to, well, streets. These streets, however, aren't made of brick. They dissolve rapidly, so you need to keep your eyes peeled in order to notice them. 6. Rayleigh scattering shift. What you might see as the sky getting darker during twilight is actually an epic light show. I'm not talking fireworks here, but a more subtle transition as the heavens basically get their house in order, showing different shades of blue and red. Why do the shades alter? Well, there are very small nitrogen and oxygen molecules in our atmosphere. They're too tiny to see, but their presence is revealed as the sun shines through them. The sunlight acts a little like a drink pouring down over a bunch of ice cubes. It bounces, scatters, and splashes around. As it does so, the light spectrum is splintered, and we start to see these colorings. They call it the Rayleigh scattering shift, after the British physicist John William Strutt, who described it in 1871. He was also the one who first educated people on why our sky is blue. 5. Microseismic noise spikes. Instead of seeing an ocean as a large mass of water, it's better to imagine it as a bunch of forces all competing in a big watery competition. The tidal forces can be incredibly powerful, which is what leads to the natural phenomenon of microseismic noise spikes. These are tremors below the surface, amplified by wave systems, or waves moving against each other. they become what are called microseisms, which spike and become detectable by marine equipment. The noise spikes aren't noisy in the usual sense, where you can hear them. The noise is more what experts pick up on their seismometers. You can't blame human beings for not noticing these signals. They are hard to spot, unless you're an oceanographer or other type of expert. 4. Capillary wave suppression zones. Wind is guaranteed to disrupt the surface of the water, creating ripples. Or is it? Surprisingly, it doesn't always happen. In the case of capillary wave suppression zones, you may see small areas of water that are super smooth. They even stay that way on a windy day. So, how do these zones stay ripple-free? For that, we need to look at stuff floating on top, like oil or soap. The chemical slick basically flattens out the water, making it unlikely to be disturbed, unless a really big wind comes along. It's a dramatic example of how pollution can interfere with the natural progress of our seas and rivers. 3. Leafy boundary layer detachment. There's a lot going on with leaves we don't know about. A leaf boundary layer detachment happens when wind picks up speed and lifts a layer of air off the surface of the leaf. Yeah, that's right. I said a layer of air. Turns out air can stick to a leaf, though it's a fleeting thing that's easily blown away. Is it a big deal? Well, if it could talk, the leaf might have something to say about it. The boundary layer of air gets in the way of water evaporation, a process called transpiration. It also interferes with the exchange of gases, where carbon dioxide is absorbed and oxygen is released. Now, I don't know if you know this, but oxygen is pretty important for us human beings too, so it's probably for the best that this boundary layer on the leaves doesn't stay for long. 2. Cryogenic fracture pings. What happens when ice or rock splits apart? It makes a ping approximately a fraction of a second long. Now, this isn't a ping as you'd hear with a cell phone notification. In fact, if you ever heard this sound, it'd be more like a What you're hearing is a sudden release of energy which forms acoustically. It's called elastic strain energy and is released when tough material contracts through changes in temperature, producing cracks. The sounds are studied by experts who want to know what a chunk of rock or ice is going to do. You might almost describe it as nature's voice, though one you'd really have to strain to hear properly. 1. Gravity wave ripples. Can gravity disrupt clouds? That's news to me, mind you, but this list is all about natural moments most people miss. Air is pushed upwards in large sections by weather systems such as storms, and gravity pushes that air back down in a wave motion, altering the shape and appearance of clouds. Sometimes a big chunk of air is pushed through the middle of a cloud, leaving a bullet-like hole. It isn't all forceful, though. The process can also be gentle, with patterns on the surface of clouds made by the gravity waves in air. Witnessing what the waves do to clouds allows us to briefly study the impact gravity has on our environment. These natural moments were magical, but not everything nature does is like that. Sometimes it's plain bizarre, so much so that it feels like it shouldn't exist. Find out more in this video, ready to watch right here. As always, don't forget to like, share, comment, subscribe, and I'll see you in the next one for a whole new list. Notification bell too, do that.